This film is about the niche, or as some people call it, the niche. Regardless of what you call it, it's a really important concept in ecology because it helps us understand the geographical distributions of species. And we're going to use the forest in the Dandenong Ranges to explain just how niches might apply in the natural world. I'm in front of a mountain ash, Eucalyptus regnans, magnificent forest tree that you find in southern Australia. So how would we define the niche of a species like this? Well, a good starting point would be to map the distribution of where the species occurs. So if we take every known location and put that on a map. Importantly, we need to know where the species doesn't occur as well. Now, for all those places where the species does occur and the species doesn't occur, if we collect something about the abiotic environment, we can start to understand the preferences and tolerances of this species. So let's think about how we'd do that. For every known location of ash, if we knew something about the rainfall, both the annual rainfall and the monthly rainfalls, something about the temperature, the minimums and the maximums, and perhaps the mean for the year, and something about the soils, perhaps fertility, and we could use nitrogen availability to tell us something about that. If we know something about those places where ash occurs and those abiotic environments, we can compare that to where it doesn't occur. And we can define the tolerances of the species, the niche, in a very broad sense. This is called, at its simplest level, the climatic envelope, if we just look at temperature and rainfall, and then that would be moderated by soil fertility within that envelope. That's called the realised niche of the species, where it's currently found. Now, maybe this species could also be found outside that current distribution, in what's known as the potential niche. So that's places where the species could grow, but currently doesn't. That occurs because sometimes this species hasn't dispersed to those areas yet. Perhaps it's because there's been too frequent a fire regime. Perhaps there's been some disease that's killed off the trees in those areas. So the realised niche is where the species is currently found. The potential niche is where the species could potentially grow across the landscape. Now let's think about how we might test this idea of niches in a local scale here in this forest. And we're going to focus on two tree ferns to ask this question. In this forest, there are two major tree fern species. And we're going to test the idea that they have similar or different niche requirements to exist in this forest. To do that, we're going to look at their distribution across an environmental gradient, a gradient of moisture availability. But before we can do that, we've got to identify the two tree ferns. Let's have a look at the first one. This is the first of the tree ferns in this forest that we're going to examine today. It's called the soft tree fern, and it gets its name from the fact that at the base of each tree frond, is quite woolly and hairy. It's soft to touch. Some other characteristics to spot this species in the forest. You'll notice that the girth of the trunk is quite wide. It's about so wide, so they're quite big. They grow to about 3 to 4 metres in height, and you'll notice that the tree fern fronds can be often persistent. They hang on to their dead fronds, and that makes them easy to spot in the forest. This is the second of the tree ferns that we find in this forest, and it's called the rough tree fern, Cyathea australis. Now, the rough tree fern gets its name from the rough nature of the base of the fronds. They're like sandpaper, they're rough to touch, so they're really obvious to tell from the soft tree fern. There are a couple of other features of this tree fern that make it a little bit different. You'll notice this time the girth is much narrower. They're rather slender tree ferns. The height of this species can be much taller than the soft tree fern. I've seen examples of these tree ferns up to 8 or 9 metres in height. Magnificent examples of tree ferns. So the spotting characteristics allow us to tell the different species apart. Now we're going to examine something about the distribution of these two species in this forest. So, if we want to work out the preferred niches of these two tree fern species, we might want to examine their distribution, their abundance, in relation to a key environmental gradient. And in this site, that gradient is likely to be something about moisture availability. Ferns, after all, tend to grow where it's moist. So what we might want to do is look at the distribution of the two species, count the number of individuals, and plot those numbers relative to how wet or dry a site is. And today we're going to use position along a slope to tell us something about how wet or dry the site is. By quantifying the abundance of a species on this gradient, we can work out what might be the role that moisture plays in the distribution of that species. Now, we wouldn't expect the distribution of the two species to be exactly the same. Niches tend not to overlap exactly. They'll be slightly different. So we're looking to see if the two species sort themselves out according to this environmental gradient of wetness. Let's start in the creek. Here we are, right down on the creek line, so it's the wettest part of the environment. And on our gradient of site wetness, this will be the place that is the wettest throughout the year. Currently there's water flowing, the humidity is quite high, and because we're in a valley, it's quite sheltered in here. It rarely gets windy and the sun doesn't shine in here nearly as much as it does higher up the slope. When we look around, we can see that it's soft tree fern that is dominating this site. There are no rough tree ferns in this site at all. So in the wettest part of the environment, soft tree fern is very common. Let's now go about 50 metres up the slope, away from the drainage line, to see what tree ferns are growing in a slightly drier environment. We've come up about 50 metres from the creek line, and I can see around me, from the persistent tree fern fronds, that this is still a pure stand of Dicksonia antarctica, the soft tree fern. So despite the fact we've come out of the creek, and it's a little bit drier here, because of gravity, water is draining down to the creek, so it's a little bit drier, but still a pretty wet site. Dicksonias are the only species occurring here. So far, we've only started to quantify the distribution of Dicksonia. We need to get to the edge of this species range in this forest to work out where its tolerances lie. Let's go another 50 metres up the slope and see how things change. We've come another 50 metres up the slope now. So we're 100 metres out of the creek line, and things are starting to change here. Immediately, I'm noticing there are fewer soft tree ferns, and importantly, the rough tree fern has become obvious in this site. So if we plot the niche distribution of rough tree fern, we can immediately say it's a species that requires slightly drier conditions than the soft tree fern. Soft tree fern is a species that's found in very wet environments, it appears, whereas the rough tree fern appears to grow in slightly drier environments. What's changed about the site? Well, being further away from the creek, it's going to be drier, it's probably less humid, it looks like the forest is more open, there's more light here, so that could lead to greater temperatures, it's just warmer up here. That's all going to influence moisture availability through the entire year. So we might hypothesize that the soft tree fern is a species that requires high moisture throughout the entire year. And Cyathea, the rough tree fern, might be a species that tolerates drier conditions. Let's go up the slope a little bit further and see what changes 100 metres upslope from where we currently are. We've come much further up the slope. I've beat my way up through the forest, maybe up another 100 metres. So we're 200 metres away from the creek. And around me, what I see is only the rough tree fern, Cyathea australis. There are no Dicksonias here at all to be found. So we've come to the edge of the distribution of Dicksonia. Clearly it's got too dry. It's Probably much better drained soil here, not nearly as wet, quite open, probably a little bit warmer, and I suspect it dries out more. Cyathea, by comparison, if we were to plot its niche distribution, is clearly a fern that tolerates drier conditions than the soft tree fern. Let's go up a bit further upslope, we'll beat up again, and see if we can't find the edge of Cyathea's distribution. That way, we can work out where the species started and where the species stopped, and that tells us something about its tolerances on this moisture gradient. Well, we've come up quite a long way on this slope. We're up near the ridgeline now. Cyathea has finally dropped out, so we found the edge of its distribution here. Up on the slope here, it's drier, no doubt. The soils are shallower, they're less organic. Humidity is lower, there's lots of light, and I suspect in summer it gets quite dry here. And I think that's what's really important to the distribution of both of these tree ferns, how wet it gets or how dry it is in summer. Let's sum up about the distribution of these two species and how that defines their niches. Dicksonia seems to be found most abundantly near the water source, where it's wettest. It's found there exclusively with no Cyathea. As we move up the slope, there is a zone where the two species overlap. And it's at this zone Dicksonia drops out and Cyathea appears. Cyathea then is found for quite some considerable distance up the slope. It's clearly tolerant of drier conditions than Dicksonia. The two species appear to have very different niches, with very little overlap between the two species. And that's how niche coexistence allows species, or niche differences allow species to coexist in mountain forests like this. They have very different niches despite the fact they're both tree ferns. And hopefully we've been illustrating here the way that niches help us understand plant distributions.